Okay, so the next question is looking at a Born-Haber cycle, and it's looking at identifying what two of the different delta H's are, delta H1 and delta H2. And delta H1, we've got strontium chloride being formed from its constituent elements in their standard states. That is the classic definition of an enthalpy of formation. In delta H2, I've got 1 mole of strontium solid going to 1 mole of strontium gas. It is therefore the enthalpy of atomization of strontium. You need to refer to it as the enthalpy of atomization of strontium, because there is also a later point in the expression, equation 5, which is the enthalpy of atomization of chlorine. Okay, so you need to refer that specifically delta H2 is the enthalpy of atomization of strontium. Okay. Now, I know if I follow my arrows round, I can work out my equation for my Born-Haber cycle. So, this enthalpy of formation arrow is going down, so I need to go against it. So I've got minus delta H1, plus delta H2, plus delta H3, plus delta H4, plus delta H5, plus delta H6, plus delta H7 is equal to 0. And then rearranging, I end up with delta H7 equals delta H1 minus the sum of delta H2 to delta H6. And if I plug my values in, that gives me an answer of minus 2,114 kilojoules per mole. Okay. Now remember that I am going against the arrow here, which would make it positive, but then I'm rearranging so it becomes negative again. So it's minus 828, minus 164, minus 548, minus 160, minus 1060, minus 242, minus 728 rather, which gives me that answer of minus 2,114. In part B, why is the lattice energy of magnesium chloride more exothermic than strontium chloride? Okay, well the first one says that there are more cation to anion interactions in magnesium chloride. That is not true. You're comparing MgCl2 with SrCl2, so the number of interactions is exactly the same. Second one says the interionic distance is smaller in magnesium chloride. That is true, because magnesium has less shells and therefore its ionic radius compared to strontium is smaller. So therefore the distance that the magnesium has to be to the chlorine is less. Third one is to say that magnesium has less covalent character. Again, that's not true, because if the magnesium is smaller, it's going to distort the chloride ion more, so that is not true. The fourth one says the magnesium ion has a greater charge than the strontium ion. Again, that's not true. They both have a 2+ charge. And in fact, the effective nuclear charge of magnesium is greater than the effective nuclear charge of the strontium because it's smaller. The answer is B.